There's a lot of focus on improving models. That has been the case in academia and industry for a long, long time. But turns out that a lot of these problems are to data. Garbage in, garbage out still holds for all of these data. So when using AI models, several issues related to data can significantly impact the performance, the reliability, and also often the fairness of these outputs of the models.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. This season, we're exploring the many ways we can harness the power of artificial intelligence to learn about our world. I'm also on a personal quest to discover if AI will be more of a help or more of a hindrance to our work as geoscientists. Last episode, we chatted with Dr. Caleb Robinson, Principal Research Scientist at the Microsoft AI for Good Research Lab, to learn some of the basics of AI and geoscience. Through our conversation, we quickly realized that there's a very important ingredient necessary for reliable AI results: quality data. Data is the new currency in this digital age. It is the ultimate game changer that is powering this digital economy. But here's the thing: data can be flawed, biased, and downright misleading. We've seen it before, from super biased job screenings to sketchy surveys. Bad data has led to some pretty awful and misleading results. And with AI models becoming more prevalent in research and daily life, it's time to get serious about data quality. This is where data-centric AI comes in. Today, we're speaking with some data dynamos who are tackling the challenges and finding solutions to produce top-notch data for AI models. So buckle up, folks. It's time to get down to earth and talk data. This episode of Down to Earth is brought to you by the Geoscience and Remote Sensing Society's technical committees. As part of the world's leading professional association for the advancement of technology, the GRSS technical committees are innovation hubs, bringing together experts from around the world to forward cutting-edge geoscience research, development, and applications. To learn more and be part of the premier community driving the future of geoscience and remote sensing, visit grss-ieee.org and join a technical committee today.
I think a lot of the issues related to ethical use, responsible AI, all of this framework, I think needs to start from data. I think model is a small part. Yes, model could be biased too, depending upon who's tuning the model, who's developing the algorithms. It could induce the bias, but ultimately it starts with data.
This is Dr. Manil Maskey. He leads the Data Science and Innovation Program for NASA Science at NASA headquarters, which falls under the Office of the Chief Science Data Officer. He also leads NASA's Earth and Space Science Data Informatics Office at Marshall Space Flight Center. Through much of his career, which has spanned more than 20 years and has included roles in government, academia, and industry, Manil has been very attuned to the importance of data. His interest and expertise in data systems, cloud computing, artificial intelligence, and visualization have reinforced this emphasis on quality data over quantity, though quantity is still very important for large AI models. Manil is now sharing his knowledge to enhance data science that's tailored to the unique demands of the scientific community, particularly in the world of AI.
If we are talking about AI from a data perspective, we need to be responsible about how that data is being generated, how that data is being processed, and also how that data is going to be used for modeling. And when we talk about ML-ready datasets or ML-ready datasets for Earth observation, these standards are a little bit restricted. So it is important to have specific use cases which will deal with these attributes.
And this is Dr. Rajat Shinde. Rajat works on NASA's Interagency Implementation and Advanced Concepts, or IMPACT team, where he focuses on data-centric AI and foundation models. He's currently working on the multi-mission algorithm and analysis platform and foundation models for geoscience, where his research areas include above-ground biomass data-related research and data-centric AI, respectively. Rajat is also one of the lead collaborators on a neat project that is helping to improve geospatial data for AI algorithms worldwide. We'll hear more about this project later in this episode, but first, we need a better sense of the intricate and complex challenges of data in AI. So let's get started. Today, we're talking about data, and data is one of the most important and also most challenging components of ensuring AI models provide accurate outputs. So, Manil, what are some of the issues that crop up with respect to data when it comes to using AI models?
So when using AI models, several issues related to data can significantly impact the models. These issues can be categorized into the quality of the data, the quantity of the data, the representativeness of the data, and now more and more with generative AI, we're seeing the privacy and security of the data. When you talk about quality, you can always relate it back to noisy data and erroneous data. There are examples in land use, land change when certain things are very difficult to classify because they're so similar when you look at it from the computer vision perspective. And models usually get those confused. And those are either the noisy part of the data or sometimes erroneously labeled, right? And there are also inconsistency with the data, such as the different formats that we have in geospatial data. There are sometimes conflicting information about the data, right, which are labeled by supervised learning process. So that can confuse the model and lead to unreliable predictions. And there are also issues related to quantity of the data. As we all know, AI models need lots of data to train, right? And if you don't have enough data, it doesn't generalize very well. And this is particularly the case in geospatial data, especially on the in situ side of the things, when you need to validate these information using ground information. You generally don't have enough of those. And there are many reasons for that. Number one is the cost issue, right? For each 5 by 12, 5 by 12 image to label that image, it costs about $5, right? You need thousands and thousands of that. So there's a reason there is an insufficient amount of data. Then related to quantity is also this notion of imbalanced data. If we look at information, geospatial data is quite imbalanced. You have lots of samples from continents like North America and Europe. There are very few samples for certain cases from continents like Africa and South America. So that's another issue. I think we all know about bias, the training data bias. Our society is biased. So this part of the sampling that data, you get lots of biased data. But what happens is if you don't take care of that in the data side of the things, the models actually exasperate that information and predicts biased information. And there is the issues related to privacy. Now we have very high resolution data. What that entails is you can get into very detailed information about people. So give an example of agriculture, right? If you have a high resolution data at sub-meter scale, you can probably figure out socioeconomic information about that particular agricultural area and the well-being of the people. So you have to make sure you consider those things because there are now security risks related to that.
Wow, that's a lot to tackle when it comes to getting good data. So, to recap, we've got issues with image quality like noise and incorrect labels. Then there's a problem of AI deciphering different data formats. We're also missing crucial in situ data to double check AI results. And to make matters worse, our data is biased towards certain regions with far less data available from the global south. You also mentioned the growing worry about privacy and how we need to consider ways to keep sensitive information safe. That's a lot of issues, and it seems pretty daunting.
Yeah, that is correct.
Rajat, do you have anything to add?
I guess Manil covered most of the things. Most of the effort or emphasis has been on the modeling side. And now, since the amount of data which is being curated daily is ever going to increase, so high time we not shift our focus, but maybe emphasize on this aspect as well.
I completely agree, Rajat. So, one of the terms that we're hearing a lot right now is data centric AI. What does data centric AI mean?
Yeah, so maybe it's helpful to understand the counterpart, the model-centric AI first, right? Model-centric AI means that we've seen this in the, especially in the academic community. You're given a data set, right, like ImageNet, and you're asked to improve a model for a given task, right? finding cats in the image or something like that, or classifying land change. That's the modality of model-centric AI, which means given a data set, a fixed data set, you continuously improve the model. So the counterpart of that is, given a fixed model, can you improve the performance of the model by iterating on the data? So in the simple term, that is what data-centric AI means. It's a framework within the AI landscape that emphasizes the engineering of the data and doing that systematically to build a robust AI systems. So that is how I would explain what data-centric AI means.
Okay, so basically, data-centric AI is an approach that focuses on adjusting the data, as opposed to the model, in order to improve quality and accuracy. What are some of the systematic ways we do this?
So it has a set of steps for each part of the AI lifecycle, right? I can start from maybe the training phase, right? There is several different ways to improve the data during training phase. There's something called data augmentation you can do. Like I said, there's not enough data in some cases, so you can use techniques like transformations. What that means is applying geometric transformation is one example, like rotation, flipping, scaling the satellite images to artificially increase the diversity of and size of the training data sets. The resulting effect of that is a generalization, right? You can have more samples to train the model. There are also synthetic way of doing the data augmentations, like generative adversarial network. They can be used to create synthetic information, and we use that quite a bit in satellite remote sensing use cases. Like I talked about noise, right? There are also ways to use data-centric AI, especially techniques called confident learning. What that allows you to do is look at distributions of the data, usually comparing the distributions of the data in true labels versus the noisy labels, right? And then try to prune that information so that you remove the mislabeled data information. There are techniques like active learning. What active learning allows you to do is iteratively select the most informative unlabeled samples, which can improve your modeling, right? So manual labeling is pretty rigorous and time consuming. So this active learning approach actually helps you to label this manually, but very systematically so that you get the most out of it. And there are also ways to use the class imbalance problem I mentioned earlier. There are ways to address that using information like relevance-based weighing, where you actually only pick the information that gives you the most information about a particular location or time. For example, if you're doing use land cover classification, and if you're looking at Siberia, you probably don't need a lot of samples from there because things over there don't change very often. But if you look at tropics, right, you need lots and lots of samples because the dynamics there is changing so fast. One more thing to add is the data-centric AI actually covers the full life cycle of AI systems, right? Once you deploy the AI systems in production, data-centric AI doesn't stop there, right? There are practices within the data-centric AI to monitor that data for various aspects of new data coming in. One good example is COVID, right? Look at language model. Before 2019, the first version of ChatGPT had no knowledge of COVID-19. So how do you continuously improve that? So it doesn't stop by just once you develop the model. I think you have continuously monitoring and auditing the information. I think that part is also data-centric AI.
Right, so there are all these different options for improving the quality of your data. But are there standards developed for this work?
Yes. So AI is moving so fast that I think we're having to rethink some of these ways to build standards. What we have been doing from our side is trying to leverage fast-moving community to lean on them in terms of standard development related to geospatial information. And I think Rajat probably is more qualified to speak in this topic because he leads the GeoCroissant efforts.
Manil isn't talking about the French pastry here. GeoCroissant is actually a new format developed for describing machine learning datasets that helps geoscientists work with these datasets across platforms and repositories. GeoCroissant also facilitates dataset discovery. We'll dive into exactly how this new format works and what it means for geoscientists right after the break.
Want to be at the forefront of geoscience and remote sensing innovation? Then join one of the Geoscience and Remote Sensing Society's technical committees. With 8 committees to choose from, you'll find your niche. From earth science, informatics to data fusion and climate technologies, our committees are driving progress and advancing the state of the art in geoscience remote sensing work. Through our networks, you'll collaborate with global professionals, participate in cutting-edge research, and apply innovations to real-world challenges. Enhance your career, expand your network, and contribute to a better tomorrow. Visit grss-ieee.org and join a technical committee today.
Welcome back. Today we're talking data-centric AI with Dr. Manil Maskey, Data Science and Innovation Lead at NASA's Office of the Chief Scientist Data Officer, and Dr. Rajat Shinde, Computer Scientist Level 4 with NASA Impact at the University of Alabama in Huntsville. After reviewing the many issues we're facing when it comes to data quality, I'm left questioning if AI and geoscience might be more trouble than it's worth. I mean, people make mistakes when working with geospatial data, but AI's massive processing power and its often black box nature means the scale and impact of mistakes made by AI are potentially way bigger. That said, Manil did outline several ways we can improve data quality, from implementing data augmentation and transformations during the training phase to confident and active learning techniques for better interpreting noisy geospatial data. There's also a brand new project called GeoCroissant, and it's all about standards, which of course, I love. Introduced in April 2024, GeoCroissant is the new format developed for describing machine learning datasets that helps geoscientists work with these datasets across platforms and repositories. It's basically a standardized metadata system that specifically includes characteristics crucial for defining geospatial datasets for AI. I'm super excited to learn more about this new standardization and how it's helping put data-centric AI on the map. Maybe it'll change my mind on the helpfulness of AI. Let's see. Let's talk about this croissant. My French teacher will kill me if I make this wrong. Croissant, or is it, well, let's just make it general, croissant project in particular. What is this project about? How does it work? How is it helping us address AI data issues? Rajat.
A croissant, and I'm not talking about the one which we eat, but the project for the metadata standard. So, croissant is a collaborative project under the ML Commons working group. The idea is to describe the metadata, which is details about the data or data of data, in a proper standardized format based on schema.org. So, schema.org is a vocabulary which is developed collaboratively by a community, and it defines attributes for all the attributes which are available over the internet in a structured data format. So Croissant project uses that vocabulary for defining attributes related to data and how we can use it directly for our machine learning workflows. So the project in itself, it's an ecosystem which comprises of the core standard, which is a way of defining your data, defining the metadata of your data. It also includes tools related to how you can generate across all formats a specification, or how you can define your data in that particular format. And on top of that, it also includes facilities to directly incorporate data loaders, including TensorFlow data loaders or PyTorch data loaders in your machine learning modeling.
This is very cool. So, right now, where are we in developing these standards so far? And where is the Croissant project hoping to go?
That's a great question. So there are a lot of scope in croissant development, and it's an active work ongoing. One important aspect of Croissant is its integration with the data repositories. So, as Manil specifically mentioned, that we have integration support with the dataset search side, where there are Google Dataset Search and Kaggle Dataset Search, OpenML Search, where the users can come in and search for datasets related to their particular problem. And on the other side, we have integration with repositories and libraries like TensorFlow and PyTorch data loaders. So what this gives us is an end-to-end workflow for searching for better data sets, and then maybe fine-tuning those data sets, and then using those data sets for particular applications in an end-to-end workflow directly from data loader perspective. From this, one important aspect came into in that there are different communities, different scientific communities, which involve data to be transformed according to their domain. So, for example, for geospatial data, we need geospatial based transformations. The attributes are different. For health domain, the attributes would be different. So the croissant is designed in a way that the modularity is achieved if you want to extend that particular standard. So there is a core standard, but then there could be extensions similar to geospatial, which is geocroissant. And all of these can be combined together to generate the entire metadata for your dataset. One big advantage of this is that nesting is now possible. So you can fuse the data from multiple domains together and use it for your analysis. And going forward, in the current scenario, the discussion is going towards how we can use LLMs or large language models to generate the croissant files and incorporate the data quality standards or data quality attributes in croissant metadata so that it is a comprehensive metadata description where you don't have to look here and there and you have all the important things required in the specification.
So, if I'm understanding correctly, GeoCroissant is an extension or add on to Croissant that includes geospatial specific metadata and transformations. Is that correct?
So, yeah, as we discussed, croissant is a way of representing your metadata from the data. And from a project perspective, it includes various aspects. You have specification, which is a standard way of defining your metadata. You have tools and technologies. So GeoCroissant is designed or is planned to design in a sense that it would incorporate the attributes which are specific to geospatial data and are not included in the core croissant specification. So things like resolution or sensor characteristics or even the statistics or central values which are being used for normalizing the data. These things, if they are not designed in the core croissant specification, so we are planning to put it in GeoCroissant.
Hmm. I read that there's also a responsible AI extension. Can you tell me about this?
Sure. So responsible AI specification came out of the need for defining standards or defining attributes related to doing AI or both from the AI data perspective, which goes in the input, and from the output of what comes into, and defining those attributes for the society. And this includes a responsible AI toolkit, which goes into the Croissant editor, as well as the vocabulary, which is developed based on some use cases. So these use cases are defined for biases, for safety, for data collection. So a simple example could be a lot of the AI models use annotated data, which is generated by manual annotation. And these manual annotations could have their own biases depending on the demographics of the annotators. So the responsible AI extension, it includes all these details and gives you attributes to define in your metadata so that you have the information about biases and all these things in the standard.
So maybe I can add to what Rajat elegantly put it. It is probably also helpful to discuss what responsible AI is. So we view it as a set of steps or even practice when we design, develop, and ultimately deploy these AI models, right? Are they being done in an ethical manner, transparent manner? Can we hold people accountable in terms of developing the data sets and models? And ultimately, are they aligned with societal values, right? So responsible AI practices allows us to build that trust among users and scientists and the model developers. And these responsible AI practices allow us to prevent these biases and discriminations. And I go back to the societal and environmental impacts. People don't talk enough about the actual environmental impacts of these large AI systems. They are not helping reduce the ecological footprint, right? So we have to consider that as part of the responsible AI too.
Right. Thanks for defining that, Manil. And how is this responsible AI extension being applied as part of GeoCroissant?
Yeah, the idea was that in a geospatial domain, so safety and responsible AI is an important aspect, and it is overlooked in a lot of sense because the data is still coming in and we are busy generating models, but there are important aspects which need to be discussed. So if we have high resolution agricultural satellite imageries and I can generate insights related to those imagery, we can definitely get socioeconomic details about any particular neighborhood. And then it creates a risk in that, because going forward we don't know what a particular nefarious application could be related to that high resolution analysis. But it is one of the important scope going forward, because data quality, data privacy, and addressing biases is something which we are actively looking forward. Specifically with respect to geospatial data, we need to understand that location is prominent information related to a particular individual or a particular group, and that needs to be catered accordingly whenever we are providing data in public.
Yeah, that is a good point. So, I really love talking about standards, but a lot of people groan when I mention them. It's not exactly a sexy topic, but I'm wondering if you could tell us, why are standards so important?
I'll give a short example for this. Let us say we have two organizations, and in one organization, there are people who do not follow standards, just work on their own, and it is good. There is flexibility in the development, there is creativity which they can cater to. But then there is another organization which has a set of rules and regulations of designing variables in a code, or designing certain aspects of version control. And then when you have to onboard a new person, or you have to onboard someone who is not in the part of organization, then for the first organization it becomes really difficult to rapidly continue the development or rapidly continue the processing. The reason being, you take a lot of time to understand what is happening there, as compared to the second part. Since everything was happening in a standardized way, now it is very easy for you to jump in and collaborate and contribute. So the idea here is standards make it really easy to do interoperability and also modularity. So when I talk about interoperability, what it means is, even if I have multiple standards, multiple rules defining different domain, how do I combine them together to work in a interoperable environment or interoperable system? And when I talk about modularity, it deals with the extension. So we all know that going forward, science is going to progress, and there will be new scientific developments every day coming in. The question is, how do we keep the previous developments in sync with the new developments and introduce them in a cohesive system? So this is the role where standards play a very important part. And if we have designed set of rules, then we can definitely include new developments in the existing system. With that in mind, it becomes even more important with the development of foundation model and large language models, because these are rapid developments. Every day we see new models being developed, but the data is not changing with that frequency. The data is mostly constant, although it has a life cycle, but it doesn't change that frequently. So to incorporate that, we need to address issues like, okay, what is the temporal expiry date of a particular data? What is the useful time period of a particular data? So all these things are important with respect to geospatial data as well. And with data-centric approaches, it becomes easier to define these attributes, so that the person or the user, whoever is using it for their particular modeling approach, they have information about it. And that is important.
Yeah, I think just to key on that last element, earlier I talked about some of the ways data-centric AI helps the community and the model developer, right? From our perspective, from NASA's perspective, we collect a lot of data, right? And we also put a lot of resources in developing data for AI. So just imagine users being able to come to a system and search and discover data with all of these facets that are related to data quality, data quantity, representativeness, data governance aspect, right? These are all elements that are being discussed or already implemented as part of the croissant, right? So if you implement that and put tooling around it, I think it will maximize the value of the data curation that we've already done for AI and data in general.
Mm, mm, mm. So this season, I'm trying to figure out for myself whether or not AI will be more of a help or a hindrance in our geoscience work. Given our chat about data challenges, AI standards, and responsible AI, what are your thoughts on this?
Oh, it's definitely going to help the geospatial community. I think there are several ways it can help. We are mostly focused on the downstream side of the things, like analysis side of things, right? With the amount of data we're collecting at NASA, currently we have about 140 petabytes, and it's going to get to about 250 petabytes in 2 years with NISAR launch. So it's not possible for us to not rely on these techniques to either process or analyze the data, right? It's just humanly not possible. So that's the downstream side of the things. If you look at getting the data from these missions and putting it into the hands of people, that is the upstream side of the things, right? There's a lot of things that goes on before it even gets to the AI workflow. And data-centric AI is one of the key component of that. How do you make these data AI ready and make it available for people to use? GeoCroissant comes into that picture, right? So all of these things are done by human right now, and it's a mundane task that could be augmented using AI, right? So when you look at the big picture, looking at both from the upstream and downstream side of the things, not just focusing on the analysis side of things, I think the efficiency gain in terms of scientific process is just too valuable for scientists and application developer, where they can rely on these AI techniques to improve their processes. That it's only going to benefit the science and geospatial community in particular.
That was beautifully summed up, and I just echo on those thoughts. AI is definitely going to help. There are some insights which we cannot expect to understand from human understanding or human level of expertise, but AI can provide us of those hidden insights and definitely be useful for actionable insight. And on this note, I would also mention that we, as a part of GRSS, IEEE GRSS, Earth Science Informatics Technical Committee, have several working groups, and we have started a recent Earth 2 working group, which will be focusing on AI for foundation model and digital twin and data-centric AI as separate tasks in that. And on that note, I'll also call our listeners to join the effort of GeoCroissant. We need help, and AI is going to not hinder the geoscience processing, but definitely be helpful. We'll ensure that.
Unlike oil, data is not a finite resource. With the abundance of digital platforms and modern technology, we can collect data continuously. However, simply gathering data is not enough. The real challenge lies in ensuring that this data is beneficial, meaningful, and ethically handled. And I think this is a key factor in determining whether AI will ultimately benefit or harm society. In my view, a data-centric approach helps us make informed decisions that also help us address global challenges. And like what Manil and Rajat said, we need to pay careful attention to ensure appropriate quality, relevance, and context of the data, because even the most sophisticated data-driven models can lead to misleading conclusions. I personally believe that building systems such as the GeoCroissant will provide us with structured information for managing data quality, which makes me feel more positive about AI being a help overall. In order for us to make data-centric AI more efficient, we obviously need to look into the infrastructure that facilitates AI systems. So in our next episode, we'll dig deep into AI hardware and infrastructure with NVIDIA solution architects, Dr. May Casterline and Dr. Brent Bartlett. To learn more about Croissant, visit mlcommons.org. Details about the GeoCroissant and responsible AI extensions can be found on the earthdata.nasa.gov blog. Finally, you can connect with Dr. Manil Maskey and Dr. Rajat Shinde by contacting them through the Earth Science Informatics Technical Committee, which can be found by visiting grss-ieee.org and selecting this committee under the Community menu. Be sure to follow and rate us on Spotify and Apple Podcasts, and support our sponsors on social media at IEEE_GRSS on X and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films, with help from me, Stephanie Tomampos. Graphics and design by Mylene Briggs of Kila Media, And a special thanks to Manil Maskey and Fabio Pacifici for their support. I'm Stephanie Tumampos, and you've been listening to Down to Earth.